Descriptive, and the second one is inferential. Descriptive means the summary information that we know already, right? Mean, median, mode, standard deviation, variance. All these are the different functions we use in descriptive analysis. That is the job of our data analyst. After cleaning the data, after applying some manipulations on the data, change the data types. So this is where you need to concentrate more. Okay. And this inferential statistics is for the next level. Like, for the data analytic in data analytics, predictive analytics is there, right? So inference means prediction. So we know that what is inferential statistics. Let us see the topics one by one. Again, we'll just want to recap. So inferential statistics means it's a branch of statistics that makes inferences or predictions about a population based on a sample of the data. Okay. It uses probability theory to estimate the likelihood of certain outcome or relationship. So it basically completely based on the probability theory. So by using this, we can get conclusions about the entire data. Okay. See, while traveling today, I just assuming that when we were working in the software, I mean to say, we started career in the 2007, right? 2007, 1997 itself. But in 1997, there is no company here in Hyderabad. Only Satyam Computers is there, mainframe that too. Okay, at that time, whenever I get any problem in the coding, suppose as I started my career as a data backend developer, database developer, basically. There we used to solve the problems by taking some help from the Stack Overflow. That is one of the famous. We can also follow that. Stack Overflow is the website. There is a portal which contains the problems solved by different people. The same kind of problems will be there. There we can get the sample and also the solutions. But now ChatGPT overcome that complete Stack Overflow. So very, very less people are going to that website, that portal. Okay. Why? Because why I am telling the story here. Stack Overflow has given the data sets freely for all the people. We can access that solutions and the problems and the people by getting the API calls. Okay. So this ChatGPT got the data, complete data. So based on that data, they are predictive. This analysis applied now. Understood now? So that is how this predictive analytics works. That is inferential statistics works. So based on the existing data, the new data or patterns will be created. That is called the inferential statistics methods. Okay. So sampling, estimation, hypothesis testing, confidence intervals. Let me give you a small, in interview point of view, what they will ask mainly for the data analysts. I just recorded some information. Let me go through this. Give me a minute, guys. Okay. The frequently asked questions about this are related to data analysts, guys. Can note down this. What is descriptive statistics? We'll see the examples also that related to the existing this inferential statistics. Before that, I wanted to tell you where is that notepad? Okay. So what is descriptive statistics? So you can tell that the descriptive statistics is the initial step in understanding and summarizing the data in a simple term. In a simple term, what will tell? It serves as the initial step in understanding and summarizing the data. That is the descriptive statistics. So it serves as initial step in understanding and summarizing data. So if they ask you deeply, like you can tell them like it involves organizing the data and then visualizing the data, summarizing the raw data. Like that, you have to tell the main uh, key aspects. Okay. Okay. Then what is inferential statistics, guys? What is inferential statistics? This takes the data analysis to the next level. This takes data analysis to the next level by drawing conclusions about populations populations based on a sample. Okay. So now if they ask you deeply about this subject, guys, overall I'm telling you, I'm concluding simple terms like what you will do in descriptive statistics, or what are the key aspects if they ask you this descriptive statistics. You can tell them measures of central tendency, nothing but the descriptive statistics, guys, including mean, median, mode, and mode, which offer insights into the center of data distribution. Under this is the number one. Number two, we have measures of dispersion, like variance, standard deviation, and a range. So this is the category in this measures of dispersion, guys. And the third one is visualization. So creating graphs, histograms, bar charts, and also already, right, box plot is also important one. It can be used for visualization purpose, guys. That's it. So if you tell these three things, that is enough for them, so that they can get that. So you have the complete understanding of the descriptive statistics. So if they ask you to solve, this is our range only, then on overall you have to tell them what is the inferential statistics. So in this again we have different categories, guys. Here we have sampling techniques. Okay. So this relies on selecting samples from a population. This is number one. Number two is hypothesis testing. So this involves setting up hypothesis about population characteristics. The third one is confidence intervals. So these provide a range of values. See, there is a big theory, but I am not just giving one line kind of a answer for this. These provide a range of values within which we are confident a population parameter this is also lies based on sample data. This is the one line statement. And then the fourth one is regression analysis. So techniques like regression analysis to model like this, to model. This is using the ML algorithms, guys, machine learning algorithms, to model relationships between variables and predict the outcomes. That's it. So you need to remember these points. The categories of descriptive statistics are three types. One is measures of tendency, which includes mean, median, and mode. Measures of dispersion, variance, standard deviation, and range. Visualization techniques using graphs, histograms, bar charts, box plots, etc. So descriptive and diagnostic statistics works only on these above methods. Okay. So these are all. And you need to go through the documents given by already. I have given you, right, all the documents material about in detailed information about this mean, median, mode, variance, standard deviation, and range, box plots, and IQR, interquartile ranges. Okay, Q1, Q3, Q2, and what is a skewed, positive skewed, or symmetric. So So you know how to find the standard deviation, right? What is the symbol for sample standard deviation, and what is the symbol used for population standard deviation, guys? This is symbol for sample standard deviation. That is S, small s. Symbol for population standard deviation is sigma. So this is symbol for population standard deviation. That is sigma. Okay. What is the difference between univariate data and bivariate data? Univariate data and bivariate data. Nothing but only univariate analysis centers on understanding the characteristics of a single variable, guys. So here univariate analysis centers on understanding the characteristics. Mhm. Of a single variable, guys. Single variable. So bivariable means bivariate analysis explores connections between connections and interactions. I told you correlation yesterday. One example, right? One variable is the one variable is depending on the other variable. That is called the correlation. That is comes under this bivariate analysis, guys. So connections and interactions between two variables. Bi means two. Important, guys. This This is, let us say, how can we denote these numbers, guys? So this is the first question is descriptive statistics. Number one, let us say Roman letters 1, Roman letters 2, this is 3, 4, 5. Okay. So this is done, done, done. Let us come to our hypothesis testing, guys. Okay. So measures of central tendency, mean, median, mode, and measures of dispersion. What are those? Variance, standard deviation, and range. Okay. And also one thing is missing, guys, here. That is IQR. Range, IQR. What is that IQR? Interquartile range. This is important. So when will we use this IQR? To find out the outliers. Okay, that is also important. What is an outlier and how will you identify them? How will you fix them? Interquartile range. What is the IQR, guys? The difference between first quartile Q1 and the third quartile, right? Q3. Q3 minus Q1. So that you need to understand and tell that in our, if they ask you what is IQR in detail. So we know that the measures of dispersion, the third one is measures of position is also there. Okay. Measures of dispersion. A small correction, guys. Let me give you this one. This is the third one. That is measures of position, guys. Okay. Here we derive that quartiles. What is a quartile? And IQRs, percentiles. Okay, percentiles, already, right? What is percentile, guys? What is percentile? A number divided by 100 is a percentile, right? That is also derived like a percentile, quartile, quantile. Quantile means here 50%, guys. So measures of position, quartiles, percentiles, IQR, and also the important one is Z score. Z score. So that means, what is Z score? So can I write on this here? Z score means a standard score that indicates how many standard deviations. That indicates how many standard deviations a data point is from the mean. A data point is from the mean. See, this is important, guys. Z score is important for our data analysis. Why? Because this is going to apply to replace the outliers by using the score. Let me go through the that is there in a data cleaning section. One second. The formula is for Z square, Z score. Z is equal to x minus mu divided by sigma. That means here mu means here mean, guys. Mu is nothing but here mu is nothing but here mean only. And sigma is nothing but, what is sigma? Standard deviation. So once we derive this Z score, if we have to fix the outlier, remember this point, guys. Whenever we find any outlier, we will find out using this formula, and then we have to check whether that value is, this Z score should be greater than 3 or less than minus 3. Less than minus 3. Okay. So they will ask you this question, what is Z score and what is the range, the standard range to fix the outliers? What is the range here? Plus 3 or minus 3, less than the Z score. So how will you calculate the Z score here? Z score is equal to x minus x. What is x here? The data what we are getting. Suppose if it is a age entered wrongly or some number entered wrongly in that column, that is x, guys. Okay? X minus mu. Mu means here mean, you know already. Mean. How to calculate mean? Divided by sigma means here standard deviation. Deviation. Okay. Because this is our topics, guys. This is descriptive. This is important for fixing the outliers. See, why I am telling these formulas, you need not to calculate using this in Python. Just a simple formula will be there, right? In Python, just import the statistics library that will provide this Z score. See, guys, if you go to Excel also, there are some data analysis tool pack is there to calculate Z score easily. Okay. Fine, guys. These are the important questions. Then come back to our topics, that is inferential statistics, under that hypothesis testing. Okay, I'll share with you that notes. Don't worry. Okay. So these are the key terms in inferential statistics, guys. Sampling, estimation, hypothesis testing, confidence intervals. This inferential statistics provides the ranges which we believe a population parameter lies with a certain level of confidence. Example, 95% confidence level interval. So if that is achieving that, then it is a valid. Like this Z score is in between that range, that is the valid data. Like that, there are some standard confidence intervals. Prediction. It also involves making predictions about the future data or unobserved outcomes based on the analysis of the sample data. Now tell me, to do this task, first of all, we need to have the clean data. And also, clean data means which is removing that inconsistent values like outliers, replacing the null values. Okay, and formatted in a, suppose the currency, the data is in a form of a normal digits. So we have to provide the corresponding data types. That's why in our pandas EDA, we have provided the different conversions data types from text to integer, sorry, text to date with the formats. So that is all our task, guys. So overall, inferential statistics allows us to make educated guesses or decisions about a larger population based on the analysis of small representative samples. How these are using in data analytics. So people are getting confused. What is data analysis and what is data analytics? Tell me now. మీరు మర్చిపోయారు మొత్తం. Can anyone tell now what is the difference between data analysis and data analytics, guys, from online students? In this Emirpet also, so many people doesn't know. Institutes also. Hey, don't copy from the chat GPT. No, I don't see that. Yes, excellent. This is the right answer. Data analytics is, see, data analytics is the complete overall, like a kind of a subject, which includes data, data analysis, and data analytics. In data analysis, we used to do, there are 5 kinds of data analysis, not analytics. There are 4 kinds, right? You know, what are those? Descriptive, diagnostic, predictive, and prescriptive. So descriptive diagnostic is belong to data analysis. Data analysis. And predictive and prescriptive data analytics, like a data science applications. So without data analysis, they won't do anything. So data analysis is a subset of data analytics. I told you in the beginning demos, right? Now you are recalling, huh? Yes, thank you. Okay. So these are the different kinds of terms we use in hypothesis test, this inferential statistics, guys. Let us see what is hypothesis testing. So in inferential statistics, we have hypothesis testing and the steps how to test these samples with some examples we'll see now. Hypothesis testing is a statistical method. It is used in data analytics to determine whether there is enough evidence to reject a null hypothesis. A null hypothesis means here we have different conditions here. We'll see that. It is used to test the assumptions about population based on sample data. In data analytics, it is commonly applied to assess the effectiveness of new strategies, marketing campaigns, product features, or customer behavior changes. Predicting. Based on what? Based on the past data. Based on the past data only. Without past data, we can't do. Data analysts will work on the past data. After cleaning and after doing all this process, that will deliver to the data scientists. So this is the process of, they will apply these methods. Now, formulate the hypothesis. Number one here, null hypothesis H0 means a statement of no effect or no difference. Alternative hypothesis means H1 means a statement there is an effect or a difference. No effect or no difference. There is an effect or a difference. You need to remember this. What is H0 and what is H1? Null hypothesis and alternative hypothesis. Select a significant level, that is alpha. Typically, it should be 5% significance level. Like our Z score in between positive 3 greater than 3 or less than minus 3. Here also there is standard significance interval alpha. Performs a test, calculate test statistics, that is t tests, chi-square tests to arrive this hypothesis. So make a decision, compare p-value to alpha. If p-value is less than or equal to alpha, that is 0.05 or 5%, reject the H0. There is evidence in H1. But reject that H0, null hypothesis. If p-value is greater than alpha, fail to reject H0, no evidence for H1. Little bit confusing. You need to remember this. Null hypothesis, alternative hypothesis, H0 and H1. Okay. So here, if p-value is less than or equal to alpha, reject H0. If p-value is greater than alpha, fail to reject H0. Now, examples here. Scenario. A company wants to test a new marketing campaign. A new marketing campaign has increased customer engagement measured by web clicks. They collected the data on number of clicks before and after the campaign. Okay. Null hypothesis H0. There is no evidence in customer engagement before and after the campaign. That is mu before is equal to mu after. Alternative hypothesis means ఏం చేస్తున్నాడు తను? Are you working something? మరి ఇక్కడ విను బా. Are you working something అంటే నేను I can understand. Okay. Alternative hypothesis H1 means there is a difference in customer engagement before and after the campaign. That is mu before is not equal to mu after. Now, practical examples. See here. Let me open this. So example 1, paid t-test before and after campaign, guys. Here we have imported NumPy. You know already, this is for numerical Python library. SciPy for statistics. SciPy is for statistics libraries. So we are not going to use the formulas like what I told earlier. So we will be using direct methods provided by this stats library. Okay. So number of clicks before and after the campaign. Let us say clicks before, clicks after by creating a NumPy array by providing some sample data and sample data for clicks after also provided this one. Perform the paired t-test. So to perform this paired t-test, we have a method called t-test relative. That means here this is from the stats. What is that? Library. Okay. So basically this is a library. This is the class from that library. Or you can say that it is a, what is that? No, this is okay, alias okay. No, there is no alias here. This is direct, what you call, function, we can call function. Okay. In that we are accessing this method. We can say that this is the library. This is the library. In that there are different hierarchical rights, classes and objects will be there. In that we can say this is a class. From that class we have a method called t-test_rel. So we are passing these clicks before and clicks after. So the output of this method will be two variables. One is t statistic and p value. Then we are just printing an output, paired t-test results before versus after campaign. Just we are printing the t statistic value, this value and p value. Now we have to compare that p value. That is, if the p value is less than or equal to 0.05, reject the null hypothesis. That means the campaign had a significant impact on engagement. Just now we have seen that, right? Else print fail to reject the null hypothesis. So let me run this one. Already it is there. So t statistics value is minus 19.9. P value is 2.015. What is that? Is it the less than this value or 2 is less than or greater than p value? So what does that mean here? Reject the null hypothesis. Why? It is not less than, right? See, 2.05. Okay. So reject the null hypothesis. The campaign had a significant impact on the engagement. So that's where we see this. Let me go to this. So that is paid t-test before and after campaign. And example 2 here, one sample t-test testing if the sample mean is equal to a population mean. There also we have the direct formula, the direct method here, the same method. So one sample t-test testing if the sample mean is equal to a population mean. So declared one exam score sample data, null hypothesis, the average score is 85, that is a population mean, and perform one sample t-test. That is, if you want to perform, we have a other method like one sample t-test underscore one sample from the stats library, let us say library, or in our OOPS concept we can call it as a class. Okay. So exam scores we are passing as a parameter and population mean also we have passed here. So t statistic and p value, the result output. Okay. Here we are printing the results here. Interpretation: if p value is less than or equal to 0.05, reject the null hypothesis or fail to, see here 0.7 is there, p value. Let us say, run this again. Okay. So reject the null hypothesis, else fail to reject. Why? Because this is 0.07 which is less than or equal to This 0.05. So fail to reject the null hypothesis. The average score is not significantly different from 85. Okay, like above, we tested with a, what is that method here? Paired t-test. It is paired t-test. This is one sample t-test, guys. Okay, here example 3, chi-square t-test, testing independence between categorical variables. So as I told you, this always this inferential statistics is dealing with the bivariable. Bivariable means more than, like, two variables, not only two variables. So testing chi-square is depending on that variable. Let us see that example 3. Chi-square test, directly we have here sample data provided, data is equal to numpy of here testing the independence between categorical variables. The variables here given as rows, male and female. The data given as 50, 60 and 30, 40. This is an array, an numpy array stored in the data. So this data is a numpy array data, right? So we are passing that to chi-square. Chi-square contingency. This is the method. So what is that means? We have to go to the deep data science kind of things, formulas. So we don't need that. So chi-square test results independence between gender and campaign type. That is chi-square stat, that is this stat and p value and DOF value. Okay, and the interpretation here. P value is less than or equal to 0.05. The results, what is that? Expected frequencies are 48.88 and 61.11, and this one is 31 point. This is for males and females. So fail to reject the null hypothesis. There is no significant relationship between gender and campaign type. Comparing those results by using these methods, guys. Okay. So chi-square test and type 1, type 2 errors, guys. Errors occur in hypothesis testing when incorrect conclusions are drawn. Type 1 error means false positive. This is false positive alpha. Occurs when we reject the null hypothesis H0 when it is actually true. When it is actually true, it occurs when we reject the null hypothesis. That is H0. It means detecting an effect when none exists. None exists here. Example, concluding that a drug is effective when it is not. A drug is effective when it is not. The probability of a type 1 error is denoted by significance level alpha. This is called type 1 error, guys. And type 2 error means false negative occurs when we fail to reject the null hypothesis H0 when it is actually false. That is, it means missing an actual effect. Example, concluding that a drug is not effective when it is actually is. So the probability of type 2 error is denoted by beta. Type 2 error beta, type 1 error is alpha, and these are all always checking with p values, guys. Balancing this type 1 and type 2 errors will be decreasing alpha reduces the chance of type 1 error but increases the chance of type 2 error, and increasing the sample size can help reduce both the errors. So Python code for simulation of this type 1 and type 2 errors here. So there is a, yes, now tell me. see, from SciPy stats, in this stats, we have a function or a method, import that method. So that directly, instead of, what is the purpose of this one, guys? Instead of importing all the functions, all the methods, just only whatever we need, binom test is required. So we are going to use that in this result. So we are defining a function to perform hypothesis test on a coin flip experiment. So we are passing here flips, number of flips, and head count and alpha. There is here, see, performs a binomial test to check if the coin is fair. Flips, total number of coin flips, heads count, that is number of heads observed, alpha is the significance level, that is 0.05, returns the reject H0 if coin is biased, else fail, returns this one if coin is biased, else fail to reject. This is the function of the entire program, guys. So result is equal to binom test, we are passing heads count, flips and 0.05, that is significance level. Alternative method is two-sided. We are providing the parameter. See, automatically it is taking everything, all the parameters. So we are checking here. Now this is a user-defined function, guys, from here to here. We are calling that function here again. So this, okay. Heads count, we are not giving that, just only some random numbers we are giving. How many number of flips here? 30 flips, 30 times we are flipping a coin, number of flips. Okay, that we are passing to this binomial random method under this random object, binomial function or the what do you call, or the method from the NumPy library. We are passing this heads count. This is a random data which generated by this random library. Then flips is here, number of flips is 30. The rule is we should have at least 30, guys, to get the results. So here heads count is equal to, again we are taking that binomial flips comma 0.7, that is a biased coin is P is equal to 0.7. So type 2 error is, this is a type 1 error, and this is, see here we are calling this function, guys. What is this function here? Whatever we defined in this coin test by passing flips and head counts, and the default parameter already fixed as alpha is 0.05. This is to find the type 1 error, and type 2 error is here by passing this coin test. Only here we have to pass, we are changing that value 0.7. So type 1 error is, example is fail to reject, coin is fair. Type 2 error is fail to reject, that H0 coin is fair. So this is the data that is provided. If you want to give the actual data, we have to give that instead of random numbers, we can select the data and apply this on the big data set. Okay. Greek and Latin ga undi idi. Yes. Don't worry. This is for the data scientists. Okay. We are not going to work on this. Just I'm telling you, this is the concept they are going to use in the advanced data analytics. The last one is here, ANOVA test, or this one here, Z test or T test. So here, what is Z test here? D tests and T tests are statistical tests used to compare means and determine whether there is a significant difference between sample data and a population, or between two groups. The choice between them depends on the sample size and whether the population standard deviation, that is alpha, is known. If we know this value, we can identify this test here. What is this alpha here? Just now we have seen that, right? In our notes. Z test here. What is sigma here? Standard deviation, guys. Sorry. Moving. Standard deviation, guys. This one. Z is equal to x minus mu divided by sigma. Internally, that is going to do these calculations. That is standard deviation. Okay. Z test is used when the sample size is large. That is n is greater than, that is 30. I told you right here in our example, the data sample data should be greater than or equal to 30. And the population standard deviation is known if we know the sigma. The data follows as normal distribution. And t-test here is the sample data. This is greater than or equal to 30. Here it is smaller than this. N should be less than 30. So these are the differences here. The population standard deviation sigma is unknown. The data is normally distributed or approximately normal. Key differences are here. Z test and T test. Sample size should be greater than or equal to 30, large data set, and this should be less than 30, small. Population standard deviation sigma is known. Here it is unknown. Distribution assumption normal. It is approximate or normal. Use case large samples, known sigmas, small samples, unknown sigmas. These are the differences. Okay. ANOVA test. This analysis of variance ANOVA is a statistical method used to compare the means of 3 or more groups, guys. That is only for binomial or bivariant. In the earlier one. Here it is more than 2, that is 3 groups, 3 or more groups. Advanced analysis kind of. So analysis on variances, compare the means of 3 or more groups to determine if there is a significant difference between them. So let us see the example. So we have given sample test scores from 3 different teaching methods. Method A, method B, method 3, stored in group 1, group 2, group 3, and imported the stats library and also directly stats. So it is going to import everything, all the functions. Perform one-way ANOVA. So by using here F one way directly, we have to pass the group 1, group 2, group 3 variables here. It is going to give us F statistic. This is what? This is for what? This is for formatting purpose. If it is giving more than these many numbers, we can give 2 floating. Means only give the 2 digits. 2F, 0.2F. Formatting, just formatting. Like our data, DD, MM, YY. So formatting this floating number with 2 digits. So here F statistic is printing the value, that is 20.51, and P value is 0.0001. So here reject H0 because there is the value is here 0.0001, which is less than here. So reject H0, there is a significant difference between the groups. This is how we use the one-way ANOVA in Python. Okay, guys. Just remember the definitions and the key terms. They are not going to ask you these advanced concepts. They will ask you mainly in our, one second, guys. I compiled data analysis. Give me a minute. I'll share with you an important document. This one. This is in pandas, right? Yes. So I'm sharing my screen, guys. Please let me know once it is visible to you. See, guys, it is a kind of a cheat sheet. You need to remember these questions. How to import the data, uh, the libraries, reading and writing. So importing NumPy and Pandas, you know about this. Reading and writing the data, reading CSV files by using different parameters. They may ask you, like, you know, if you want to give the data types of the particular columns automatically in the beginning itself, we can give that. And separator that colon. If it is a comma, you have to give comma. By default, it is taking comma only if you are not providing anything. So reading the data from CSV files with different parameters, reading a file that does not contain a header row. So we have to provide the headers like names is equal to with an array. Okay, read CSV. Then treat specific values as missing values NaN. So while reading the data file, we need to tell that here these are the NA values. It may be containing .n.a or n/a or null. So treat all these NA values, whatever are there, this kind of data that we can provide while reading the data itself, and we can store that inside this data frame. Column specific custom missing values. Here NA values email unknown, age -1, location not available. This is a kind of a live practical scenario based questions, guys. So we need to remember these things. You know about this data exploration, displaying the first rows, first 10 rows, for last 10 rows, sample, 5% random rows from the data frame, 5% rows randomly picking up. Info gets the summary of the data frame, describe. It provides us all the summary information, statistics, guys. That may contain how many functions here, min, max, 50%, 25% values also there, right? Shape, size columns, you know, D types, you know, and then get the data type of particular specific column, D type. If you want to convert it into float type, you have to use as type, depends on the data type conversion, indexing, correlation, a kind of a cheat sheet for your interview purpose. So make it handy, like how to get the max. Commonly used aggregate functions, guys. Product of all values, summary statistics, you know already this summary statistics of age only, age column only. Cumulative sum, cum sum. Okay. What is the last one? Minimum value in each row. X axis equal to 1. For loops here, iterating a data frame. So for index row in iter rows, we know this one, right? From the data frame. So print the index and print the row, both we can. Yes, axis equal to 1 for columns. Yes. Getting unique values and their frequencies. This is all our data analysis purpose, guys. So if you are thorough with this questions, around 100 and plus questions are there. So we can go through this and then I can attempt the interviews. We used most of the functions in our sample project, guys, like value counts, unique values, duplicated value counts, identifying and removing duplicate columns in a data frame. And the data selection, different ways, guys. See, slicing, labeling with a kind of a slicing in location, both starting and ending, various kinds of scenarios, conditional data selection, filtering using the relational operators, guys. We want to filter out only age is greater than 10. We want to combine the logical condition and or within the same data frame, guys. Age is greater than 20. So how can you do this in our SQL? Query only, right? Select query only by giving some same kind of logical and relational operators only based on the columns. But it takes more time to write the query, but it is only simple condition which we are providing within the data frames itself. So filtering rows where a column's value is specified, list, ease in method, how to use ease in, what type of method it is? నోట్లో ఉంది వచ్చేస్తుంది చెప్పండి. You have that in your tongue. Membership, yes. Use between the ranges, age between 20 and 30. Okay, inclusive both, neither left or right. And here selecting specific conditions after filtering. After filtering also we can get the specific columns, that is so and so columns here. From to n minus 1, that is 4, 0 to 4. So to filter rows where column contains a specific string, str dot contains. Changing values using LOC. See, if you want to try this, you can download this data set. What type of data set it is? Okay. You can take any data set, right? You can go to Kaggle and download the sales data, let us say sales data, or which is containing the proper appropriate data. I'll find out this one and then I'll provide this data set, guys. Okay. Unique values, duplicated here, identifying, removing the duplicate rows in a data frame, identifying, removing duplicate columns in a data frame, data selection, okay, conditional selection, changing values in a using LOC, changing values in ILOC using ILOC. Faster, see here, faster single value updates. If the data is very limited, you can use AT and IAT. Like here, at name Maruti, change name of the row with the index 1 to Maruti. Here, update first column of first row at IAT. It is faster than the ILOC and LOC methods, but limited data only. That is the condition again. Replacing values. So you can replace these. This is the commonly used data analysis. Clipping, limiting the values within a specified range, useful for in handling outliers. Adding and modifying columns. Applying functions. Like, you know, these are advanced kind of thing. Apply function is there. Vectorize function is there. Removing columns, removing rows, changing the column names. Finding missing values, important one. Filling the missing values. Okay. Please go through this one by one. This is enough for your Python interviews, Python data analysts kind of thing. Sorting the values. So, you know, sort index and sort values. Getting the largest and smallest values from a column using n largest and n largest and n smallest. joins here, guys. Merge using merge. Combine two data frames based on concatenation. Concatenating the combined data frames either vertically or horizontally. Okay. So inner join, left join, right join, outer join. Merge. Grouping, aggregations. It contains everything, guys. You can go through this and we'll discuss if you have any doubts on this EDA concepts. Okay. So it is given the example how to group the data and how to get the data. We've seen this, right, in our EDA project. It's the same kind of thing. Iterating through groups. Retrieving the data frame from a specific group. Working with things. Working with date and time is important, guys. So inserting missing dates. Inserting missing dates by using daily frequency method. So that's all. Okay, guys. So that is all for our today's session. I am stopping the recording. I will share with you these materials about the statistics as well as this pandas important EDA related methods. Okay, guys.